filtration. Filtration. So when we do the decantation process, some of the how we can find that some of the liquid will be present with the sediment. So the separation is not completely like what we can say perfect or accurate. Then we can go with the filtration process. The same decantation we'll do in the filtration process, but here we take a beaker or a conical flask. We can place a funnel on it. Funnel. You know, not inverted funnel. This is the funnel. Okay. We'll take the funnel and we'll insert the filter paper inside the funnel. Like we can prepare the filter paper and semi-fold the filter paper and one more fold. And we need to make a cone and insert the cone filter paper inside the funnel. Okay. And allow it to spread throughout the funnel. And place the funnel along with the filter paper. Just insert the funnel along with the filter paper in a container. This is called a conical flask over here. And by using glass rod, why to use glass rod? Here, suppose this is a glass rod. I just use the sample like this. Why? Because it will go very slowly. We can't pour the solution. If we pour the solution, there may be chance of filtration not much accurate or efficient. Okay, by using glass rod, I just pour the solution slowly so that we can find that the entire solid is deposited or entire solid is settled on the filter paper, and we can see a clear solution passing through the filter paper. Where did you observe this filtration process in our routine life, children?
Ma'am, separating tea leaves from tea.
Exactly. Very good. Separation of, yeah.
Like in our house, we are like removing the water from it. Sometimes we use something like a big strainer and put it into that.
Yeah. And we can use the strainers, especially this filtration is especially observed when we prepare juice. We separate the crushed juice extract. From the juice, we just take the juice extract and the crushed part will be present on the strainer. So this also we can give a simple example where we find the separation or the filtration technique in our routine or day-to-day life. Yeah. Anything else?
Nothing, ma'am.
Next. And this is also one more separation technique which is used especially when solid mixed up with liquid. When solid mixed up with liquid. Understood? For example, yeah. I want to show you this ammonium chloride. Let me show. You are
Ma'am?
Yeah, dear.
Did I miss anything?
No. From us? Okay. Have you understand by saying that video you understood how the separation technique is used? Sublimation?
Yeah, ma'am.
Yeah, very good. So next one, evaporation. And this evaporation, especially we know about the evaporation since we are learning from class 4. Alright, water cycle, evaporation, condensation, all this in general we used to learn. Yeah. So in this evaporation, especially this is the kind of separation technique used, especially when solid is mixed up with liquid. For example, how we get a crystalline salt from the seawater. So what in general they'll do this evaporation process. So they take land.
the thing you're trying to explain. Ma'am, so they just take the sea water and heat it, maybe from the sun, or they just boil it, and then they see, then there is like crystals of a crystallized salt left. The water evaporates.
Yeah, definitely. But whenever we learn any separation technique, we should compare the thing with the general or day-to-day life things, whatever happening around us. Then only we can identify the example easily. I understood the separation technique. In textbook, we learn all these things in textbooks or any other book or any other material we learn. But this separation technique, where does it happen? Understood, Neha?
Ma'am, actually, the answer was given by Vamika.
Vamika, sorry. Vamika? Yeah?
Yes, ma'am.
Good. What you said is exactly correct.
Example of evaporation in day-to-day life.
Yes, I'm giving the example. Yeah.
I wanted to ask one doubt.
Yeah, let me complete this, dear Neha.
Yeah,
please. Thank you. Okay, very good, children. Okay, so what we'll do as to separate crystalline salt from seawater. Okay, so they'll take a big land and they construct the blocks, shallow blocks. Okay, they'll construct shallow square shaped or different shaped blocks and they'll insert this seawater and allow it for few days or weeks for evaporation, simple evaporation, natural evaporation. So after evaporation, what happened? The water evaporated, only the water is present, but we can make crystals. The formation of crystals from the seawater. Okay, when the seawater consists of different salts. Okay, so these crystals are present after few days after complete evaporation. They just collect the crystals from that shallow blocks. Understood? So this seawater, the crystals from the shallow blocks, and then transfer these crystals to the industry for the refining process. The process. One take this crystals directly. Why they can't pack the crystals, children? Why? Because along with the crystalline salts, there are many more impurities or many more salts present in the sea. So directly from the shallow blocks, we can't use the salt, children. They should go to the industry for the refining process. Refining is nothing but purification process. They'll remove all unwanted salts. Okay, they'll remove all unwanted salts and they'll purify the crystals and finally it will go for the production area. Understood? This is a simple evaporation technique used to separate the crystals from the seawater. But
can I ask my doubt?
Yeah, Neha.
Ma'am, that I wanted to ask that in the figure given there is something written as Bunsen burner. What does it mean?
It's a burner. The burner used in the laboratory is called a Bunsen burner.
Okay, ma'am.
We can't do the practical on cooking gas stove or domestic gas stove. No? So this is nothing but a Bunsen burner used in the laboratories. If you go to the higher classes, when you go to the laboratory, definitely you use this. Yeah.
And I wanted to say one thing that again today morning when I was eating my breakfast, I found that in the casserole upon that some water vapors or something like liquid was there. When I opened it, fall in my hands. So that means that the heat of that food item came upon and
that is simple condensation, Chem.
Yes, ma'am. It's like the same thing that happens when you do the biology activity when you tie a plastic bag around the leaf.
Yeah. It's a simple condensation. Changing the pressure, the vapors converted into the droplets. Understood? So this evaporation, have you got this, Neha?
Hello, ma'am. Yeah, can you please repeat? I haven't heard.
It's a simple condensation process.
Okay, ma'am, but I wanted to ask that in that evaporation also takes place and condensation also takes place, right?
It's a simultaneous process. Evaporation and condensation is a simultaneous process. And you have learned in standard 4, especially I think so, about the water cycle. If there is change in the temperature and pressure, evaporation and condensation will undergo in a cyclic form. Yeah?
Ma'am, I haven't understood your question. Can we repeat?
What happened? It's not clear what I have explained.
No, I understood, but you asked me something all just before.
No, I just asked you whether you understood the concept or not.
No, I understood the concept.
Very good, very good, very good. So this is a simple evaporation technique. So here we have taken a bowl of salt dissolved in water. So we can't wait for days to go for the natural evaporation process. But in the laboratory technique we use on behalf of this temperature, we use the Bunsen burner and we provide the heat. When we continuously providing the heat to the china dish containing salt and water, the water gets evaporated. The water gets evaporated. When the water gets evaporated, so until the level of water decreases, only the 3/4 of water left in the container we need to evaporate it. And leave the container aside for a few hours so that we can find the crystals. We can find the crystals are present in the dish and water is completely evaporated. That means when the salt is completely dissolved in water, but by using evaporation technique, we can get back the salt again. And this is a simple homogeneous mixture. Understood? Yeah.
Yeah, ma'am.
Next.